Hey everybody, Mrs. Bodechon here. We are going to look at 9B on your AKS portfolio. It says, I can compare and contrast the characteristics of electromagnetic waves and mechanical waves. So we've kind of already learned about those, but now we're just going to go further in depth comparing and contrasting them. So you have this graphic organizer on your sheet, and we are going to go ahead and fill it out together. But before we even do that, I want to read this to you up top. It says, while mechanical waves can be both transverse and longitudinal, all electromagnetic waves are just transverse. So sound, for example, is a longitudinal wave. So I'm gonna show you guys that this section right here is something we're gonna learn down the road. So I don't even want you to worry about filling that portion out. So I'm just gonna cover it up with my face, okay? Now let's go ahead and look at the rest and fill it out. So we know first that the wave properties are amplitude, wavelength, frequency, and wave speed, which we're not really getting into very much, but that's just how fast the wave's moving, right? So then underneath the waves, there are two different main types, and we're going to look at the first one. The first one is electromagnetic waves. Now, examples of electromagnetic waves are these right here: X-rays, radio waves, infrared radiation, microwave, visible light. There's even more, you guys, but these are just some examples for you to list. Now, underneath electromagnetic waves, you need to know that they do not need a medium, which means that they can travel through places like in a vacuum. A vacuum is like outer space, right? There's no particles, so there's no medium, but yet they can still travel through them. But it's good to note they can travel through a medium too, right? So these are possible to travel through a medium or without a medium. But they are always transverse waves. So no matter what, electromagnetic waves are transverse waves. Now, if we go back up to types, the second type of wave is a mechanical wave. So examples of what mechanical waves are, you can see they're listed here: sound, air waves, water waves, ropes making a wave, right? Earthquakes like seismic waves, tsunami waves, and of course, there is a ton more that aren't listed here. These are just various examples. So if we go down from mechanical waves, you will see that all mechanical waves require a medium to travel through. So they have to have particles which they can travel through to become a wave in the first place, right? They can be either a longitudinal wave or a transverse wave. So mechanical waves could be either or. Let's go ahead and look at your next thing. Your next thing is to create a Venn diagram on your paper. You have all these words and phrases, and you're asked to make a Venn diagram on electromagnetic versus mechanical waves so you can better compare and contrast them. So what I did is I have put all of those words into these Venn diagrams so we can go over them together. So over here we have our electromagnetic side, and over here we have our mechanical side. Under electromagnetic, you can see they travel through a vacuum, right? Like outer space where there's no medium or no particles, right? They do travel at the speed of light because it is light. Light is an example, and light's even right here. That's an example. Some examples are radio, microwaves, gamma rays, that kind of thing. So those are definitely examples of electromagnetic. If we go to the opposite side with mechanical, you can see that it does require a medium to travel through. Seismic waves, which is earthquake waves, you guys, that is a mechanical wave. Sound waves is an example. Ocean waves is an example. It's caused by vibrations. That's definitely mechanical. And longitudinal waves are going to be only mechanical, okay? Now, in the middle, this is what they both share in common, right? So crests and troughs, they are always electromagnetic. However, there are some mechanical waves, for example, ocean waves, that can have a crest and trough as well. Okay, so I put that in parentheses so you guys would know that. Okay, so the transverse, it's going to be always electromagnetic. However, there are certain mechanical waves that will be a transverse wave as well. They all have a frequency, they all have a wavelength, and they all transfer energy, right? So these things are pretty much any wave put together, what they share in common. The next thing on your paper says draw and label a transverse and longitudinal wave. So what I've done here is I've put the waves for you. We're going to look at transverse first. So you can see we have our line that represents rest or no disturbance, which is no wave. And then our wave is in blue, right? And we can see that we have our crests, which are up top, and our troughs, which are down below. Now, from rest to crest, we've labeled amplitude. You could have also labeled amplitude rest to trough. That is also the measurement of an amplitude. And then to measure wavelength, it is from crest to the next crest, or you could have said trough to the next trough, or even any point until it repeats that same point. That is also a wavelength, okay? Longitudinal waves are going to be where there's compressions and rarefactions, because this is a parallel moving wave, okay? So you can see the displacement is in a parallel fashion moving backwards and forwards. So compressions are where all the particles are being squished together, right? And then where they're springing apart and they're stretching out, that is our rarefaction that you see here. Now, it does measure the amplitude, and you can see the rest line is in between all of this. So it is still the same thing, you guys. It's rest to the top, right, or rest to the bottom. We do have a wavelength. Our wavelength is going to be measured very differently in a longitudinal wave than a transverse. We are going to go from one compression to the next compression. Something to note. If you are measuring from the end of the compression, you need to measure to the next end of the compression, right? If you're measuring from the beginning of the compression, you need to measure from the beginning of the next compression. If you're starting in the middle, you need to measure from the middle so that it will be the same wavelength each time and it will be consistent, all right? All right, guys, and that wraps up 9B. So if you have any questions, let me know. Bye.